Let us see an experiment for alert system using PIR and buzzer. PIR sensor is an input and buzzer is output. The flowchart explains powering the PIR sensor to 3.3 volts, buzzer to the 5 volts and 5 volts to the ESP32. Now connecting the PIR sensor to ESP32 as input and output to the buzzer from ESP32. Let us see an experiment for alert system using PIR and buzzer. Write the code in the Arduino IDE for the desired input and output device selected to perform this event. Assign PIR sensor in any digital pin, here we assign with GPIO 17. Similarly, we assign GPIO 16 for buzzer. To activate the pin function, we use the pin mode for PIR as input and buzzer as output. Now we code inside void loop. Read the PIR sensor value using digital read and temporarily store in any variable. Here we allocate PIR state and use the condition to check if the PIR sensor is high, buzzer will be activated. If it is low, relay will not function, using if condition. Now save the program and click the tools and select the particular board and select the port and verify the program and finally uploading to ESP32. Here the circuit diagram shows the actual wire connections being used. Power the IoT kit by connecting the adapter. Connect the selected input sensor, that is PIR sensor, to the 5 volts power pin and the GPIO 17 pin. Connect the selected output sensor buzzer to the 5 volts power pin and the GPIO 16 pin. Here we connect the buzzer through bus to the GPIO pin. Power the IoT kit by connecting the adapter. Now pass through your hand over the PIR sensor and see the buzzer function. PIR motion sensor applications include lighting controls, thermostats and HVAC systems, smart home, IP cameras and surveillance systems and more. A buzzer is an audio signaling device, which may be mechanical or electromechanical. Typical uses of buzzers include alarm devices, timers, machineries and automobiles.